Hi everyone, my name is Feniello. I'm a software engineer in Microsoft Research in Redmond, Washington, United States. I've been with Microsoft about 20 years. I've worked on a dozen or more teams across several divisions, some product teams, some research teams, some in-between transitioning research to product groups. So it's quite a breadth of experience. Some of those teams using big data, some of them using just a lot of data, which is not quite the same thing. Dominik wanted me to come in and share my experience and answer a few questions. So I hope that this is useful. Alright, so what is big data? That is a good question. It's kind of an amorphous term, it means different things to different people. For me, big data is a threshold that you cross at which now your current processes no longer work, or the processes that you're architecting would no longer work. So it's kind of like the standard interview question that Google used to ask. Very simple question, just sort a list. You walk in and maybe you've studied for this interview and you just write quick sort up on the board. No problem, you've just aced the interview. And the interviewer says, you actually didn't ask how big is this list? Okay, fine, how big is this list? 100 petabytes, how about that? That's not going to fit on any hard drive. That's not going to fit in RAM on any machine. And quicksort is not the solution to that. You're going to need to partition the data, maybe sort the partitions using something more conventional, but then merge sort those partitions, maybe use Hadoop or MapReduce, something like that to accomplish all of this. It's a completely different process that's needed to process that size of data. So sometimes the data grows large enough that it's not just a simple scaling problem, it's more like your old solutions just don't work at all. Now you've crossed over into big data. So why does big data matter? So I think the point really is just that the data matters. And we have lots of sources of data that are extremely interesting and extremely useful for making business decisions. And it just so happens that it's just torrents of data coming in. Maybe it's IoT devices in the field that are gathering sensor data. It's useful for monitoring different things. For me personally, it's robots making interactions with humans that I want to record those interactions. Maybe it's products that have been released and they're instrumented, and so you want to watch how users use the product. Maybe A/B testing of different features that you plan to release and see how users react, and you can make data-driven decisions about that. So business leaders have just decided that this data is extremely useful for making decisions, and it just happens that it's extremely large. For example, if you want to do brand analysis using Twitter, or analysis of some new product that you've released, see what people are saying about it, and you want to consume the so-called Twitter fire hose. It's called the fire hose because it is just a torrent of data coming at you. So making use of all of this interesting data that's out there requires using big data approaches. And so that's why big data matters. So where has it had an impact? For me personally, it's just been in product development. So instrumenting products and shipping them, and then watching users, see how they react to feature changes and things like that, using it as a data-driven way to make feature decisions. So it's one thing to go into a meeting with a product manager who maybe has done a focus group, small focus group, or a usability study in a lab with a few users. It's something else entirely to have a product out there that's instrumented, and you can try things. You can A/B test feature ideas and get a nice statistically significant sampling from a large number of users, and use that to make your product decisions, make very small changes over a long period of time, and evolve a product rather than make a bunch of decisions up front with limited data. So big data has really helped develop good products. An example of mind-blowing big data application. So this is kind of a counterexample. This is, at least it's not my product, it's my competitor's. But I was on the live search for mobile team. We did a mapping app that did local search and maps and turn-by-turn directions. And we wanted to add live traffic to the map. So Google Maps, they had shipped a year earlier than us. This was quite some time ago. And they had just added a live traffic feature, and we weren't actually quite sure how they did that. We found out later that the way that they did that is they simply had enough users and were tracking the GPS coordinates of enough phones that they could determine the traffic flow for themselves just by watching phones flowing throughout the city. And so that's pretty amazing. I was kind of blown away by that. We had to instead partner with some traffic data provider and integrate that with our app. So having access to a vast number of users, instrumenting the products, and being able to make use of that amount of data is pretty powerful. Famous last words of advice. So I'd say, if you want to get into this, it's really not that difficult. I'd say, learn Hadoop, learn Spark. These are kind of the very common tools. Learn some of the cloud services that are applicable, like in AWS, learn Kinesis and Lambda. In Azure, learn MSMQ and functions. It's basically the same idea, these serverless architecture for just processing these massive streams of data and building these systems that just scale nearly infinitely. Speaking of creating systems that can scale nearly infinitely, it's like Rich Hickey says, we're now living in the space age. Every time you go to S3 storage and ask for more storage, it always says yes. There is no such thing as running out of space in the cloud, and it's very easy to create systems that literally do scale infinitely. The only forcing function is just cost. And that's usually a requirement that's not passed down to the engineering team, and so it's something to watch out for. It's quite fun to do, and it's so fun. I've seen teams actually apply these tools to problems that aren't big data problems, just because it's fun. So that would be my second bit of advice, really, is make sure that you apply these pretty heavyweight tools to problems that really deserve this kind of tool. The solution comes with its own problems. Now you have these clusters of machines and this configuration information to maintain, these Rube Goldberg pipelines. If you're going to solve it in a more traditional way, maybe do that. Maybe wait until it's really clear that you're on the horizon to meet the inflection point for needing big data solutions before you start applying these tools. On the other end of the spectrum, sometimes big data problems are something that we create for ourselves. Maybe instrumenting a product, just instrumenting absolutely everything because we don't want to decide up front what we care about, and so we're just ingesting this massive amount of data only to throw away 99% of it. How about if we make some decisions up front and maybe it can be reduced to a non-big data problem up front. So that's maybe my next bit of advice. Try to think of the whole spectrum end to end, and maybe try to avoid big data if possible, but apply it when it's necessary. It's a very powerful tool.